Somewhere in a forest right now, a tree is remembering something that happened to it 50 years ago. Not in words, not in pictures, in chemistry. A moth once bit into its bark as a caterpillar decades before you were born, and the tree never forgot the taste of it. That memory is still sitting inside its cells today, waiting. But the real truth is even stranger. That tree isn't just remembering for itself. It's been quietly telling the trees around it too. You probably think of memory as something that happens in a brain. Neurons firing, images forming, a sense of, I remember this. Trees have none of that. No brain, no nerves, no moment of conscious recollection. And yet, when scientists went looking for something that behaves an awful lot like memory inside a tree, they found it. Not a metaphor, an actual mechanism. Here's where it gets uncomfortable, in a good way. In the early 1980s, a researcher named David Rhodes ran an experiment that quietly rewired how biologists thought about plants. He let insects chew on willow trees, then measured the chemistry of nearby undamaged willows. Their leaves changed. They started producing more tannins and phenolic compounds, defensive chemicals that make leaves taste bitter and harder to digest. The untouched trees were arming themselves before a single insect had touched them. Rhodes's work was controversial for years. Some scientists dismissed it as noise in the data. It wasn't noise. It was a signal sent through the air and later through the soil. Picture a single leaf being torn by a caterpillar's jaw. That small, sharp puncture releases volatile organic compounds, invisible gas molecules drifting off the wound like a scent. You can't smell it. Insects and neighboring plants can. It's the plant equivalent of a scream, except the scream isn't for help. It's a warning broadcast to everyone nearby, including a version of itself that will exist decades later. Now zoom out. Not just leaves and gases drifting between branches. Go underground. In the late 1990s, a forest ecologist named Suzanne Simard, working in the forests of British Columbia, used radioactive carbon isotopes to trace something almost nobody believed was real. She wanted to know if trees were feeding each other. What she found was a network of fungal threads called mycorrhizal networks, connecting the roots of different trees into something that functions less like separate organisms and more like a single distributed system. Sugar moved from tree to tree through fungal threads thinner than a human hair. So did chemical signals, so it turns out, did warnings. Here's the sensory version. Imagine kneeling in a forest and pressing your palm flat against the cool, damp soil beneath a big tree's roots. It feels like nothing. Dirt. Silence. But threaded through that soil, invisible to your hand, is a living communication network older and more extensive than anything humans have built. Some scientists call it the Wood Wide Web. It's not a cute nickname. It's functionally accurate. So how does a tree remember an attack from 50 years ago inside this system? This is where the science gets genuinely strange. Trees don't store memories in a hippocampus because they don't have one. Instead, they store something closer to a chemical scar. When a tree is wounded or attacked, it doesn't just react in the moment. It alters its own epigenetics, meaning it changes which genes get switched on or off without changing the genetic code itself. Think of it less like rewriting a book and more like dog-earing certain pages so they open faster next time. A tree that has been attacked once can prime its defensive genes to switch on faster and stronger the next time a similar threat appears, sometimes for years, sometimes researchers suspect for decades. A researcher named Ian Baldwin, who has spent much of his career studying wild tobacco plants in Utah, found something remarkable about this priming effect. Plants that had experienced insect damage responded to future attacks with dramatically faster chemical defenses than plants that had never been touched. The plant wasn't just reacting anymore, it was anticipating, based on something that had already happened to it once. Have you ever flinched at a sound before you consciously realized why? That's roughly the plant version of it, minus the consciousness, plus a chemical signature instead of an emotion. Here's the twist though, because there always is one. This isn't just about a single tree remembering its own history. Some of that priming can be triggered in a tree that was never attacked at all, simply because a neighboring related tree sent a warning through the fungal network decades ago, and the recipient tree's chemistry shifted in response. In certain species, especially in stands of related trees like Douglas fir, that shared memory becomes less my scar and more our scar. A memory doesn't have to happen to you personally to live inside guide you. Why would evolution build something this elaborate? Trees can't run from danger. They can't relocate when a pest moves in. A tree that lives for 2, 3, sometimes many hundreds of years has exactly one strategy available to it. Get better at surviving the same threats over time, and get its neighbors, often its own offspring growing nearby, to survive them too. A forest, seen this way, starts to look less like a collection of individual competitors fighting for sunlight, and more like an intergenerational insurance policy quietly paying itself forward. There's a researcher named Monica Gagliano whose work pushed this idea even further, and drew real controversy for it. She ran experiments dropping potted mimosa pudica plants, the ones whose leaves fold up defensively when touched, from a small height repeatedly. At first, the leaves folded every time, a defensive reflex, but after enough repetitions with no actual harm following the drop, the plant stopped folding. They had, in some functional sense, learned that this particular disturbance wasn't dangerous. Weeks later, without any further drops, the plant still remembered. They still didn't fold. Critics have pushed back hard on how to interpret this, but even skeptics admit something in that plant's chemistry was tracking time and repetition in a way that looks uncomfortably like learning. Think about what that means for the tree standing outside your window right now, if you have one. If it's old enough, it may hold a chemical record of a drought that happened before your parents were born, a late frost, an infestation that swept through the region a lifetime ago. None of it is stored as a story. All of it is stored as readiness. The tree doesn't know what happened to it, but some version of its cells behaves as though it does. Here's the part that should genuinely unsettle you a little. Human memory, the kind you experience every day, evolved for exactly the same reason tree chemistry did. Not to preserve nostalgia, to predict danger before it repeats. Your fear response, the tightening in your chest when you hear a sound that resembles something bad from your past, is built on the same underlying evolutionary logic as a willow tree bracing for a caterpillar it hasn't met yet. The mechanisms are almost nothing alike. The reason for existing is identical. Prepare now, based on what happened before, because the past is the best predictor available for what's coming. So the next time you walk past a stand of old trees, especially a cluster of the same species growing close together, you're not just looking at plants sharing sunlight and soil. You're looking at a slow, patient communication system running on chemistry instead of thought, carrying warnings past root to root, sometimes for longer than any human alive has been alive. A moth bit into bark half a century ago, and somewhere underground, that bite is still being remembered. Somewhere in a forest right now, a tree is remembering something that happened to it 50 years ago. This time though, you know it isn't alone in carrying that memory. The forest around it is remembering too.